Hi, welcome to my video on solving trig equations with the angle b times theta minus h, and this is part 6. I wanted to do some extra problems to show you some other aspects of doing trigonometry. So let's look at a couple of problems that I've made up extra. Solve for theta, where 0 is less than or equal to theta is less than 360. Notice you're in degrees, and you're going to have 0. You can't have 360, and the angles in between. We have an equation which is sinusoidal. Y equals 4 times cos of a half times theta plus 10 degrees plus 1. And this is a horizontal line passing through where y is -2. But remember, graphing is not a good way to solve, so we'll write out we'll write out the equation y 4 cos a half theta plus 10 degrees plus 1 equals -2. Because both of them are equal to y, then they're equal to each other by substitution. So let's solve this for cos. So 4 cos 1/2 theta plus 10 degrees equals -2 minus 1. 4 cos a half theta plus 10 equals -3. And we divide by 4. 4's cancel. So cos of a half theta plus 10 degrees is a -3/4. Now the reason I made up this one, because most times we've had a 0, 1, -1, a half, -1/2, √3/2, √2/2, etc. But this time I got a -3/4. So let's continue and we'll see. So we'll let a equal a half of theta plus 10 degrees. So that means we have the cos a equals -3/4. So we have a negative number, so use the calculator, or we look at the reference angle. We have to have a positive fraction because the reference angle is always in quadrant 1, which is always positive. So notice this time with the 3/4 we have to use our calculator. Here's the calculator, and we'll turn on the calculator. The calculator, this is in degrees, so this calculator is in degree mode. So we'll work out the cos of 3/4. Cos of what angle gives me 3/4? So we go inverse cos of, we have 3/4, so we go 3 division 4, or you can go decimal 75. So that gives us 41.4 degrees. Move that away. So what we have is the reference angle is cos to the -1 of the 3/4. So that comes up to be 41.4 degrees. Notice the difference. I had to use the calculator to determine this reference angle. And we have to find out where we're going to, what quadrants this angle is in, and we're going to add sugar to coffee. That's all sine, tan, cos are positive. Or we can use the cash rule. But if we say the cash rule, we have to start in quadrant 4, C-A-S-T. And we have cos is negative. Cos is positive in 1 and 4, so it's negative in 2 and 3. So we draw the terminal arm out in 2. We draw the terminal arm in 3. Reference angle is 41.4. Reference angle is between the terminal arm and the x-axis. And this is the rotation. So that means that A is, notice the rotation in the second quadrant is always 180 minus the 41.4. And that gives us 138.6 6 degrees. The reference angle in the third quadrant is right here between the terminal arm and the x-axis. The rotation is all the way around from the initial arm, and so A is 180 plus 41.4, and so A is 221.4. So now that we have determined the two angles, we let A is a half, so we have a half theta plus 10 degrees is equal to 138.6 plus, and we're in degrees, so it's 360 degrees in, where n belongs to the integers. And also the other one is a half theta plus 10 degrees is equal to 221.4 plus 360n, and again where n belongs to the integers. Now let's solve each of these and work them out to see what angles we have. So a half times theta, half times 10, and we write down the right side because there's no change, and we move the 5 over. So 5 comes over here, become a minus, so take 5 out of that, so it's 133.6. And now we double it, because we got a half, we multiply by 2. 2 times a half is 1. 2 times 133.6 is 267.2, and twice 360 is 720. So that one is solved out, and we'll keep working this one through. So we have n, and we say theta. So when n is 0, put 0 in right here. 220 times 0 is 0, so we get 267.2 degrees. And now we try n as 1. We put 1 in, we get 720. 720 and on 267.2 gives us 987.2. But we only can go between 0 and 360, so this angle is can't be, it's true to satisfy the equations, but it doesn't satisfy the restriction on your domain. So and we have no negative angles, so there's no need to use -1. Okay, we have a half theta plus 5 degrees equals 221.4 plus 360n, and again half theta, subtract 5 off of 221.4, and it's 216.4, and we multiply by 2, so we get theta, we get 432.8 and 720n. Now we do the same, we got n and we have theta, so when n is 0, put a 0 in here, that's n is 0, we get 432.8. And notice we can only go as far as 360, even though 432.8 makes the equations true, but we can't use it, so no need to do the 1. So the only answer for theta is 267.2 degrees. And again, problem is different because I have to use my calculator to determine what the reference angle is by doing the inverse function or second function, cos or sine. Okay, we have another one to do. This one's a little bit different. Just wanted to do a different problem. I keep doing the same problems all the time. you don't learn much. Solve for theta, where theta is less than or where 0 is less than or equal to theta is less than 6.28. Notice now we don't have, this is not a degree. Notice we also don't have radiant in terms of pi. But because that's 6.28, that's a radiant in terms of a decimal. So if I wrote this down and said less than 2 pi, everything would be okay. You work out the answers in terms of pi. But pi is 2 times 3.14, which is 6.28. So that means these answers had to be as a radiant in terms of a decimal. So that means, let's look at, if we're thinking that way, we look at the unit circle, and the unit circle is, we think of a 0 degree, we think of a 90 degree, we think of a 90, which is a pi over 2, and a pi over 2 is 3.14 divided by 2 is 1.57. This is 0 here, and this is 180 degrees, which is pi, and pi is 3.14, so this is 3.14. And right here we have 270 degrees, which is 3 pi over 2, and you change that to a decimal, and you get 4.71. So this one right here is 4.71. So this is a 0 radiant, or it's 6.28. So it's different. Instead of pi, instead of degrees, we have radians in terms of decimals. So let's work on this idea here. And before I just want to continue, just to make sure that 2 pi is 6.28. Pi, which is 180, is half 3.14. Pi over 2 is a half of 3.14, which is 1.57. And pi over 3 is 1.05. And pi over 4 is 0.79, and pi over 6 is 0.52. Use your calculator. I just wanted to show you that if you were using pi over 2, you got a 1.57. But if you go with the angles, see this angle here is a 60. 180 divided by 3 is 60, so a 60 degree angle would have a radiant measure of 1.05 on the unit circle, etc., etc. So let's continue. Just wanted to just explain that, because I haven't done many problems related to this as a radiant in terms of a decimal. So we have two equations. So we let each equation is equal to y, so we'll let them equal each other. So sine of 2 of theta minus 1 plus 1 half is equal to 3/8. So because they're both equal to y, then they're equal to each other. Also notice that most times you got theta subtract. Notice as a radiant, it could be pi over 2, could be pi over 3, or pi. Also, this could be a degree, but it's not. This is a 1. So that 1 is in terms of the radiant. So the 1 is in terms of the radiant. So notice again, this is a radiant, and this is a radiant. And a radiant in a unit circle, the most radiants you can have is 6.28. And this is 1. So this is 1.57. So if you go up here, 1 is about right here when you rotate on the circle as in terms of a radiant. Let's continue to solve this equation. Notice we have equations, and the LCD is combinant 4, 2, and 8. The LCD is 8. So I'm going to multiply each part of the equation by 8. When I do that, that means the fraction should go. So what we have is, we're going to multiply by 8. 4 into 8 goes 2. So that gives me 10 sine 2 theta minus 1. Half of 8 is 4. 8's cancel, I get a 3. So the 8's cancel, I get a 3. 2 and 8 goes 4. So now I have no fractions. So let's continue to simplify. Sine 2 theta minus 1 equals 3 minus 4. 10 sine 2 of theta minus 1 equals negative 1. Divide by 10, and I get sine 2 theta minus 1 equals negative 1/10, which is a decimal 1, negative decimal 1. So we let A equal 2 theta minus 1. So the sine of A is negative 1/10. Notice this is negative, so we'll do the sine of the reference angle is positive 1/10. Again, we have to use our calculator because this fraction is not a half, root 3 over 2, root 2 over 2. So, but we have to be careful. Notice this is radian. On my calculator, when I turn it on and clear it, my calculator, if you can see it, I want to make sure, is in degree mode. So I have to change my calculator to radian mode if I'm going to work these out. So I hit this button and I scan over to radian and hit enter. And now my calculator is in radian mode. That means I can work this out in terms of a radian. So it's 1/10. So inverse sine of 1 division 10. I could have said 0.1 or 0.1. And that gives me decimal 1 on the rate as a radian. So the reference angle is in terms of a radian. So it comes out to be 0.1. Again, a little bit different. This problem is different. I've designed it to be that way. So we need to go and find out where we're going to draw these. We're going to add sugar to coffee. And sine is negative, sine is positive. Here and here, so sine is negative in 3 and 4. So we draw a reference angle in 3, a reference angle in 4. Put that's the terminal arm in quadrant 3, terminal arm, and the reference angle is 0.1, 0.1, 0.1 is between the terminal arm and the x-axis, between the terminal arm and the x-axis. So the rotation is this, and the rotation is this. So notice we're going all the way around. Notice this is, now this would have been a 180. This could have been, normally would be 180 degrees, or normally would be a pi, but now it's, in terms of a decimal, 3.14. That's the difference. So A is 3.14 plus 0.1. So A is 3.24. And here, A is, and this is 3.14, but this is also 6.28 when you go all the way around. So it's, instead of being 360 minus the reference angle, it's 6.28 minus 0.1. So A is 6.18. Now let's continue. Again, hopefully trying to make you help understand when you're working with the radian as a decimal. So now we got A, so we'll change the A is 2 times theta minus 1 equals 3.24. And notice now we would be saying 360 times n, which is in degrees. You could say 2 pi times n, but the 2 pi is changed to 6.28 n, where n belongs to the integers. And the same for the other one, just 6.18. Okay, now simplify this. 2 theta, 2 times theta, 2 times negative 1. And we move the 2 over and add it on. So we move the 2 over and add it on to here. We get 5.24. Now we divide by 2. And 5.24 divided by 2 is 2.62. 6.28 divided by 2 is 3.14. And I just want to mention that, again, this is instead of 2 pi, instead of 360, you got 3.14, which is a pi, which is equivalent to 180. So again, let's work this one. I want to work both of these before I... And we're going to, you got to subtract 2, so we're going to add 2, so it's 8. 6.28 add on 2 is 8.18. And we're dividing by 2. Divide by 2, 4.09, 3.14. So I have them all worked out. Now I'll have to work out with n and what theta is. So again, we're going from 0 to 6.28. So we put n as 0. So we put a 0 in here. We get 0. So we get 2.62. We put a 1 in, and we get a 262. Put a 1 in, we get 3.14, and that ends up to be 5.76. And I'll put the 2 in, so we put 2 in here, like 2 times 3.14 is 6.28, and when you add that up, that comes out to be 8.9. Okay, notice between 0 and 6.28, so this one is okay, this one is okay, so this one is not. It doesn't fit into the domain. So let's go over and do this one. So we have n and we have theta. So n is 0, so put a 0 in here. 3.14 times 0 is 0, so we get a 4.09. Put a 1 in, we get 4.09 plus 3.14. N is 1, and that adds up to 7.23. 4.09 is okay, is in between. 7.23 is too much, so we can't use that one. And there's no negatives, because if you use a negative, then you have to subtract. And if you use a negative 1, what would happen here if you had a negative 1? So if we use, what happens if we use a negative 1 right here? So we get 2.62, subtract 3.14. So if you put a negative 1 here, you get that. That will give you a negative number, so we can't use it. What happens if you use a negative 1 here? We got 4.09, and that would be negative 3.14. And if we subtract that, and I just use the calculator here very quickly. Sometimes when I use my head, things don't work out right. So I'm subtracting. So, 4.09, subtract 3.14, and that gives me 0.95, which fits. And a negative 2 would be too far down, so we have this one, 4.09, 0.95, 2.62, and 5.76. So I'll put them in order. The smallest one is 0.95. The next one is 2.62. Next one is 4.09. The next one, 5.76. So there's 4 of them. Again, hopefully you can see the restricted domains in terms of a decimal, in terms of a radian, and notice how this problem varies a little tiny bit different than the other ones. Because when you're working with degrees, when you're working with a radian in terms of pi, everybody's okay. But when you work in terms of a decimal, students get mixed up a bit. So hopefully everything is okay. I just got the sheet in the wrong spot. Hopefully you'll like my video. Click on the like button. And if you're not a subscriber, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my video, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.